Alright, today we're going to look at translating graphs, and we're going to use quadratics or parabolas to do this. And the first equation that we have is y equals the quantity of x plus 2 squared minus 3. And we're going to move it up 4 and right 5. So we're translating this, and remember, translating is like sliding the graph. So the first thing we need to do is write down the vertex of our graph, which in this case, we look at this 2 right here, which is the opposite of our h value. So since it's plus 2, we're going to write negative 2 down for the h value. And then this minus 3 is our k. So we write down negative 3. Now, the first thing we're going to do is we're going to graph this original equation. So we're going to create a table in order to graph that original equation. So I like to use 5 points for my table. And since the vertex is the middle of a parabola, I'm going to put the vertex in the middle of my table. Now I'm going to go 2 units to the left, so, well, 1 unit each time. So negative 3 and negative 4, and then negative 1 and 0. Then all we do is we plug in these x values to get our y value. So when I plug negative 4 in, I would have y equals negative 4 plus 2 squared minus 3, which gives me y equals negative 2 squared minus 3, and negative 2 squared is 4, and minus 3 is 1. So my y value there is 1. Now I'm going to go ahead and plug my negative 3 in. So I get y equals negative 3 plus 2 squared minus 3. And negative 3 plus 2 is negative 1. So I have negative 1 squared minus 3. And negative 1 squared is 1. Minus 3 is negative 2. And now, because of the fact that parabolas are symmetric around their vertex, we can actually just flip these points, so we get a negative 2 and a positive 1 for our next 2 values. That only works, remember, if you put the vertex in the middle of your middle of your table, like I did right there. So now I'm going to go ahead and plot these points. So the first point is negative 4, 1. So I start at the vertex, which is here in the middle of the graph, and I move 4 units to the left and up 1, and I have the point right there. Then I'm going to graph negative 2, or negative 3, negative 2, which means I go 3 units to the left from the vertex and down 2. So right there. The next point I'm going to do is negative 2, negative 3, which is my vertex. So I'm going to the left 2 and down 3. And then I do negative 1, negative 2. So I go to the left 1, down 2, and right there. And the next point that I do is 0, 1. So I don't move to the left or right at all, and I just go up 1. And once I have all of those points graphed, I can go ahead and draw my parabola passing through all of those points. I gotta make sure that I put my arrows on the end of my parabola, and also I should have arrows on the end of my axes, as well as I should have them labeled x and y. So now we'll actually get into translating this graph, the up 4 and right 5. Again, we're going to need to use the vertex for this, so I'm going to write it over here so I have a little bit more space to work with it. So the vertex is negative 2, negative 3. Now, to move it up 4, up is a vertical direction, and remember k is the term in the vertex that represents the vertical position of the vertex. So we're going to add 4 because we're moving up to that value, and negative 3 plus 4 gives us 1, which tells us that the k value of our new vertex is going to be 1. And now if we are going to move it right 5, that means we're going to be adding to the h term, because h is our horizontal term for the vertex. So I'm going to add 5 because I'm moving to the right. If I was moving to the left, I would subtract. But negative 2 plus 5 is 3. So that tells me that the vertex is at 3, 1. And then the a values don't change when we translate our graph. So since a is 1, because there's not a number here, a is in front of the x up here. A is going to be a 1 as well, so we don't need a number in front of our parentheses here either. And then it's x minus h, which in this case is 3, so it'll be x minus 3 squared plus k, which is 1. So there I have my new equation of the translated parabola. And to graph this one, we're going to create a table as well. So x and y. And again, I like to use 5 points for my parabolas, with the vertex being the middle point. And then I do 2 points to the left, and I do 2 points to the right. And I'm going to give you guys just a little bit of time to try to fill those points in on your own. Remember, you're plugging the x values here on the left side of the table into the equation, so you'll be plugging 1 in for x first. And when you do that, you should get 5. When you plug 2 in for x, you should be getting 2 minus 3, which is negative 1 squared is 1, so that'll give us a value of 2. And again, since they're symmetric, we can just go ahead and flip those points. So now to graph this, I'd go over 1 to the right and up 5 to get my first point, over 2 to the right and up 2, 3 to the right, up 1, 4 to the right, up 2, and 5 to the right, up 5. And there are my points, so I can go ahead and draw the parabola in. And if we look at the horizontal distance that's happened here, we can see from the original vertex over to the new vertex, we have in fact moved 5 units to the right. And then if we check the vertical distance, we have moved 4 units up, which is exactly what we wanted to do.